All right. Well, thanks for meeting online today. My wife has her oncologist appointment later this morning, and it was going to be a tight commute. Um, but the good news is we got the CT scan results already that we're talking about. And once again, my wife's cancer is currently clean. So everybody gets extra credit. Oh, you wish. All right. So Um, what I'm gonna do here, so we for the homework, well, homework for what I suggested you should do for today is I need to let this person in. So what I suggested you should do for today is go ahead and download Unity Hub. So you would have gone to that unity.com website that I sent you to last class and downloaded all the stuff. It, depending on your internet, maybe took 20 minutes or up to an hour, maybe something like that. Unity's kind of a big thing. I have my Unity hub up here. All these are outdated because it from, projects from the past using an old version. The first thing I had done when I came in here is I clicked on install an editor and I chose here. Let's see if I click this, does it take me to it? Okay. So I went to install a Unity editor for those of you who have not done this. And you want to choose under official releases, choose the one that says recommended next to it. All right. Yours will not necessarily look like this unless you're on a newer MacBook. If you're on a older MacBook, it might say Intel based, whatever. If you're on a Windows machine, then it'll say Windows, Intel. Um, if you're on Linux, it'll show the Linux thing. I don't know if I can see the other things here because it's auto detecting me as on a Mac, but whatever. It's all the one that says recommended next to it. And then you're on the latest, greatest version that is whenever you see something on software that says LTS, that stands for long-term support. Now, if you are you're into Unity or you're into whatever program you're working with, um, if you look at pre-releases, anything that says beta means that it's probably reasonably polished, but they're still working out some bugs and stuff like that. So if you were someone who was interested in kind of playing around with the tools that are coming out next, and you were willing to deal with a little couple of quirks here and there, you could always install betas. An alpha, that's going to be pretty early on. Um, Use at your own risk, but for the course, use one of the official releases. Use the one that says recommended, so you're working off of the same thing we are doing in class. Um, okay, any questions about that? Hopefully everybody already did that, but I know that that's not how students operate. So when you actually go and do that, download the recommended thing. Okay. So when all is said and done, you should have something like this installed. Now I'm going to go here to manage just to show you. I think it should show up here under modules. So when you first go to install it, when you first go to install it, you are going to um, uh, you're going to see something along the lines of this, and the things that'll be automatically selected will be the Unity build engine and then probably Visual Studio Code. If you already have Visual Studio Code installed in your machine, like I did, it told me it was already installed, so it didn't try to reinstall it. But in any case, Microsoft owns Unity. I believe it's owns or they acquired them, and who knows what the legal relationship is, but they are tightly integrated. It comes with Visual Studio. It used to come with a choice of Visual Studio, the full Visual Studio product. Um, uh, Now it seems to come only with Visual Studio Code. Both of them are free. Just Visual Studio Code is a cross-language um, uh, developer IDE, whereas Visual Studio, their Microsoft's .NET IDE has built-in languages for C Sharp, ASP.NET, things like that. So it's much more integrated, and it has user interface builders where you can drag buttons in and things like that. So if you're building Windows specific graphic user interfaces, you would use Visual Studio probably. If you're developing in a whole bunch of different languages and things like that, like we are, Visual Studio Code is an excellent text editor that is, frankly, it's the industry standard now. Everybody who codes today, um, um, even in a base language that isn't C Sharp, unless you're doing direct .NET development as your full-time job, you're probably using Visual Studio Code. And even if you're using another product, like for example, I use Cursor. I'm sure I have it open here. Who knows what project I have up, but whatever. Um, Oh, this is actually kind of a cool one. So I use Cursor here, which is agentic coding with AI stuff. So I can go in and write the code that I want in here. But let's say I wanted to make a little, change to this to update it to the newest version or something. I can either click and say, I want to talk about this, I want to add some stuff, whatever, and it'll do some stuff automatically for me so that I can go in and just focus on the important part of the application. But Cursor here is effectively, it takes the open source Visual Studio Code and adds stuff to it. So you have a lot of examples of that in the world of IDEs where they're actually all VS Code dressed up. So just something to keep in mind, that we are dealing with an industry standard tool here that you will definitely use when you get your job. So make sure Visual Studio Code is checked when you go to install it. I would say you do not have to check any of these other things at this point. You can always add them later, like you're seeing here. So if after everything is said and done, you want to play around with trying to get the application on your Android device or your iPhone, you would go and select the right build support for that so that you can tell Unity to create a project for that device. So that's something you can always do later. All right. So once you have Unity installed, you'll go to projects here, and you will, let me just make sure nobody's in the waiting room. Okay. You'll go to projects and you'll create your new project. So I'm going to go ahead and start a project here. It'll already select your Unity organization, whatever. You can name your project whatever you want to name it. Um, as you go through the tutorial, in fact, actually, I'll show you the tutorial here first. So the homework assignment's already up for Tuesday. And what we're going to be doing is this project called Rollaball. So I'll go ahead and show you the quick video of this guy. It's only a minute and a half. So let me full screen it here. I think you can probably see this. And let's play it.
Welcome to the Rollerball project. In this beginner project, you're going to make a very simple but playable game using many fundamental game development concepts. In your rollerball game, the player will control a ball rolling around the game board using the power of physics. Your game will use player input from the keyboard to apply forces to the ball and move it around the game environment. It will also detect contact between the ball and other objects in the game so they can be collected. When the player has collected all the objects, the player wins. In this learning project, you'll use the Unity editor and its built-in capabilities to set up a simple game environment. Write your own custom scripts to create the game functionality. Create a basic user interface to make the game feel more engaging. And build your game so other people can play it. First, you'll complete the setting up the game project, Let's get started.
Okay, so that is the project that we're going to be building as our tutorial for our first Unity assignment. This is effectively a crash course that gets you, frankly, 75% of the way towards starting to imagine building games. This is going to introduce you to some AI stuff. For example, let me just forward to a place in the game here. If you had noticed, it probably was later on in it. Show me the game playing. There we go. So this, if you had noticed when it was playing, this little red guy, in fact, I'll play it here real quick, is going to be chasing the ball.
All the objects, the player wins. In this learning project, you'll
So that'll be messing with some AI where you're having it figure out pathing and stuff like that, moving around objects. Now, what's going to be, I hopefully, going to be amazing to you here. We talked about it in class a little bit last time when we were, I don't know if I put it on a slide about what a game engine is. Um, yeah, so uh, a game engine. I mentioned it's a physics engine where it handles things like gravity and things like that for you, but it also handles all sorts of other things that are kind of part of, quote, video games, where a video game doesn't have to be something that is, like a Call of Duty or something like that. It could be a utility application that kind of takes advantage of more physics-based things or something like that. Games like, so let's just quickly to maybe get you kind of interested with your, creative juices going. Take a game like Angry Birds. A game like Angry Birds, which made zillions of dollars on the App Store and is now a pretty major, gaming empire under that company. What is it, Rovio? Um, that game could be pretty easily built in Unity. Obviously, they had to put in the time to create all the different levels and what those look like, but they didn't code every single one of how those sticks and stuff interacts with each other after your pig guy hits the tower. That's all automated physics and things like that, just doing what physics does. So, building a game like that, like you could, when you're done with this tutorial, you could build a ghetto style Angry Birds already. You'll be able to do that already uh, after you've done this tutorial. The thing that'll be missing will be all the creative puzzle levels and stuff like that, because that's going to be human imagination. And then the other thing would be, the skins, the textures to make it look like the fancy artistic Angry Bird people and stuff like that. Yours will look like spheres or cubes or something like that. But you can always go and dress it up later. So hopefully that kind of gets you your mind in the direction where this is starting to move towards like building real things that people go and pay for today. And it's going to be utilizing the skills you already have. Um, okay, so I'm going to go ahead and we are going to create a project, and I'm going to name this project um, Rollaball Spring 2026. Okay. And then make sure you um, uh, choose where you want that project to be stored. Let's see, let's see, after I've done that, I think I want a local project. All right, so after you choose local project, so it lives on your computer, not up in the cloud. The cloud, I think, is free and it probably would work for one project, but I haven't messed with it, so I don't want to advise you on that. Um, then make sure the location is somewhere on your computer that you can find. So pick whatever folder you like to store your homework assignments in or whatever, so make sure it goes there. And now over here on the left is where you're going to be choosing the type of project. So the tutorial will tell you what to pick. I'm almost positive it's Universal 3D. Um, but as you kind of go through here, there's a such thing as a high definition 3D, which adds some pipeline stuff to it that you probably don't want to get into right now. Although if you choose high definition 3D and you only do the stuff that you're doing for the normal rollerball, it'll probably work fine, but you're not gaining anything from going to high definition 3D until you start looking at like AAA games or something like that. So you'll choose Universal 3D. Just to give you a little explanation of some of these other things, they have built-in tutorial projects that are in here, that you can certainly go and do if you want to just dive into these things. I think there's one from either it's here or on the website. If you click on Learn here, it shows you all these things. So I always start off with a rollerball because it's just a great introduction to Unity and immediately gets you less intimidated by it. But as you can see here, there's a 2D sprite, almost like a, Space Invaders type thing, battle game with tanks, roguelike games, all sorts of different things. I think there's kind of like a first person shooter somewhere in here as well, or it's not in here. You can find it online pretty easily. So, but in any case, we're going to start off with this rollerball thing. It's a beginner project, so it'll get us going. Um, I think you can select this project as where you want to start, but will it actually start it from here or just talks to you about it? Just talks to you about it. All right. So I'm going to go to projects. I'm sorry. I was already in it. New project. We're going to call this Rollerball Spring 2026. Choose where I want it. I'm going to select Universal 3D, this guy right here, and make sure you choose your editor version. Right now, you should only have one editor version in here, but sometimes I've been working on projects for a while, you might have an older editor put in there for a project because it works under that editor, and there's been new features that have come out since. But if you're still maintaining that old project, you may still keep that old editor on there so you don't have weirdness that comes in. But for right now, all of you should have like a single editor. So make sure that's selected. Universal 3D. Coffee, you're late.
My bad.
You're bad. You're 20 minutes late. What kind of crap is that? All right, killing me. All right. So we'll create the project and it's going to start doing its thinking thing or whatever. And I'm just going to kind of go through some of the basics of Unity today and talk about a few of the pitfalls you might run into as you get your project set up and how you might work around some of those things. Now, some of you may notice that depending on how old your computer is, that Unity may run slightly sluggishly. Oh, apparently it wants me to accept something. I have read it thoroughly. And like I said, the assignment is already up for this. And what you're going to be turning in is a short video. So I want you to screen capture and upload it to YouTube, like a 15, 20, 30-second video. And somewhere on that video, well, the video has to have your voice on it, talking about you playing your game. And then somewhere you have to announce what your favorite Ninja Turtle is. Just so I know it's really you. All right. And all those instructions are on Canvas already. But like I was saying, if you're on a little bit older machine, Unity might be a little bit sluggish for you, especially when it first launches. It might take a while to launch, but once it's up and running, you should be in good shape. If your computer is just really old and it's struggling with it, You can use one of the computers from the esports practice arena down at the other end of computer science. Those should all be able to handle it, but this should run on any laptop that meets the university's minimum requirements thingy. Okay, so now we are in the Unity editor. So this is what this guy looks like by default. So over here on the left, we have all the stuff that's in our scene. So when you're in Unity, one thing to kind of think about the way it works is um, think of it like you're making a movie. So each part of your game is a scene, and that scene is going to have various elements inside of that scene that are going to be doing different things at different times. Sometimes they'll be off camera, sometimes they'll be on camera. Notice that built in to our starting project, the sample scene, it already comes with a main camera. So there's our main camera. Um, it already comes with a directional light that's shining down on somewhere on the project. You'll want to move that to get it to make sure you've lighted your scene correctly. Um, uh, Oh, okay. Start AI companion. You'll want to and that'll all make sense from the tutorial, but just think about this in real life. If you've if it's pitch black outside and you go and put the garbage can in the middle of your driveway, nobody's gonna be able to see it. But if you shine a light on it, you can see it. So it's just like what we would imagine in real life. And then you can position the camera. So when you click on the camera, you see kind of what it is looking at any point in time or something like that. You can go and let me hide this here. So while you're working on your project, if you go up and just hit the play button, it will play your project inside of the Unity editor. And that's what your starting point should look like. It's going to look like nothingness because we haven't put anything into it. All we have is a camera and some light at this point. All right, so you can stop that there. All right, so what we're going to do is just to kind of get the ball rolling and pun intended. All right, is I'm going to go ahead over here on this left-hand side. I'm going to right click and we're going to create a 3D object. So the very first thing you usually do in these games is you'll create something like a plane. Um, so I created a plane. I'm just going to call this guy ground.
Dr. Lemon, one quick question. Did you want us to use our school account or a personal account? That was one question I had when I was.
Well, I mean, I don't care. It doesn't
All
matter to
right.
me. Um, yeah, I mean, I mean, this is just going to be your Unity account. I would say you would be in, my advice would be to use your school account because then you can more easily apply for the academic professional license, but it doesn't give you that much but do use your school account just in case. That'll be beneficial to you if you choose to get the education discount thingy. Okay, there we go. All right, so now I've added this ground to the game. Now, if I go and I play this guy right here, we're going to see that we barely see the edge of this because of where the camera is currently located. So I'm going to go ahead and I'm going to click on my camera. And let's see, is there a way for me? Okay, it wasn't on by default, but I think, okay. So for mine, when I clicked on the camera, this area down here showed up, and this kind of gives you the controls that are on here. AI navigation seems like a new thing, but tools, blah, blah, blah. The far right one is the camera. If you click on that, it shows you what the camera is currently looking at. So that allows you to move your camera around and get your game into the position you want it to be in, something like that, or whatever. All right, so that's handy when you're clicking on the camera. You can move things around and not have to keep going back and forth between playing and stuff. So we'll say that this is good enough for our uh, our camera right now. All right, let's add something else into our scene. So I'm going to go over to my hierarchy here. I'll right click. I'm going to create another 3D object and we'll go ahead and put a cube there. Notice the cube is now shown up here in the middle of the screen and it's half through the ground. So we can lift that cube up a little bit. You know, here I'll hover it above the ground here just a little bit. All right. And I'll go ahead and play the game. That way you see what the camera looks like at a higher, bigger. So we have our ground here. We have our cube. Somewhere up here is the light. So the light is shining down on this cube and we're seeing the shadow underneath it. So the game engine is doing all that stuff for us. Okay. So we'll call this, a simple scene. All right. So now we're going to click on our cube, make sure your cube is selected. And now we're going to go over here to the right and we're going to look at this thing called the inspector. The inspector lets us manipulate things related to whatever object, whatever game object. So all these things over here, these are game objects. So think of like in Java, we said the most generic top level thing is called an object. In Unity, the most generic top level thing is called a game object. All right. Now, at its core, in fact, here, let me just show you something else. I'm going to right click here and I'm going to create an empty game object. All right. So this is, if we're comparing this to what we might do in Java, I just created an instance of object. So it has only the bare minimum of what's in every single game object that might exist. At some later point in time, I'll tell you when we might use an empty game object, but for right now, let's just investigate what a game object looks like. All right, so I'm gonna come down here. We're gonna add a slide. We're gonna call this guy game object. All right, so this is the most basic element of a scene in Unity. Now, when we go and look at a specific game object, so I've selected game object over here on my hierarchy. And when we come over here to the inspector, notice the inspector is a very, very, very simple. We have something in here called a transform. So let's go back in here. So a game object is just a transform. Now, a transform, as we see here, has three subcomponents. We have position, we have rotation, and we have scale. So we have position, rotation, scale. Now, each of these guys, now this is where things might start sounding intimidating. So position is a vector 3. Rotation is a vector 3. Scale is a vector 3. Now, as soon as we start seeing things that say like vector and stuff like that on it, that's when things start feeling mathy and we get a little bit intimidated or the cold sweats or whatever it is. Let's give some definition into vector 3. Vector 3. Now I'm going to define this in terms of something you're already comfortable with. This is a 3-element array. That's what a vector 3 is. A 3-element array. Now, when you're in like a linear algebra class and you talk about vectors, you're usually talking about a matrix with, depending on how you're looking at it, either a single column or a single row. Doesn't matter. It looks like an array. All right. So for us, a vector 3 is a vector containing 3 elements. All right. So this is a structure that can hold 3 elements. It gives no definition to what those elements are, just like we can build an array that knows how to hold integers in Java, or an array that knows how to hold strings, or an array that knows how to hold generic objects. So we can put any kind of object in there, so on and so forth. That's all a vector 3 is. It says, I hold 3 elements. All right. Now, often those elements will be floating point values. And often the fact that they're stored in a vector becomes important for what Unity is doing behind the scenes for you, because there's a lot of matrix mathematics and things like that to perform transformations from one place to another place, kind of Calc 3 type stuff. But the game engine does it all for you. So you don't have to worry about this as long as you're staging things the right way. All right, so we'll go back here into Unity. And when we look at the position vector, you see we have an X, a Y, and a Z. That is, where does this guy live in X, Y, Z space, 3-dimensional space? Where is it on the X coordinate? So here, right now, I've have the empty game object. So if I slide this guy around, you see the X is changing for position. If I slide it this way, you see the Z is changing. And if I go up and down, you see the Y will be changing. All right. You're not seeing anything other than this yellow arrow thing, whatever, screen. Um, uh, He's like a half hour late. All right. So you're, other than the arrow that was on the screen, that's when you will um so you only don't see anything here because we're looking at a generic game object just to introduce stuff. All right, so position is where this guy lives in the world. Rotation is how this guy rotates in the world. Now, over here on the left-hand side of our viewer thing here in the middle, there, right now we have the move tool set up. That moves position. The next guy is the rotation tool. If we click on the rotation tool, now you see that we can, in fact, actually, I'm going to move my main camera uh, in some so we can get closer to that cube. All right. So we'll go back, we'll select our rotation thing. I've reselected the game object. So now if I click on rotate, so look at the vector 3 associated with rotation. So right now it's in the identity rotation, just 0, 0, 0. So it's in its basic thing. But if I click on this green thing and I start rotating it, what did I rotate it on? Oh, oh, yeah, I'm getting too old for this. If I want you to see the cube rotate, I need to select the cube. So we're going to go ahead and do that. So just ignore all this stuff down below here. That way we're actually working with a something you can visually see. But a generic game object is only a transform. So that's all we're looking at here. So if I do this rotation thing, you see that our cube down there is rotating. I can rotate it other directions as well, whatever I want to do. All right. So that's our rotation. That's our second thing here. If I want to put it back to its base, I'll just type in 0, 0, 0 here. So you can manipulate it through just numbers as well if you know exactly where you want something to exist or something like that. All right. Then this next thing down is the scale tool. So this allows you to make the thing taller, make the thing wider, so on and so forth. All right. So we'll go back and leave the scale where it was. All right. So back in our thing here, a vector 3 generically is a 3-element array. A game object has something called a transform, and a transform contains three vector threes. One for the position, X, Y, Z. X, Y, Z location. One for the rotation, X, Y, Z rotation. And one for the scale, X, Y, Z scale. All right. So it allows us to manipulate our things manually to get the scene set up. But then the position or rotation or scale, these things can change dynamically as our game grows. And those are things that we might be messing with. All right. Um, so let's go back here to our, I'm going to set, what was everything back? Where'd my cube go? Is he moved off the screen now? Cube. Let's see what I've done to this guy. I seem to have integrated my cube into something else. I turn one of my things off here. There, I'm going to run the game real quick. It seems like my camera thing is not updating very well. Well, then what I'm going to do delete that cube. I think me messing with it did something. All right, there's a new one down there. So I need to roll back. Okay. All right, there's my guy. I moved my camera, it looks like. All right, lift this guy back up. Okay, so now we have our cube sitting there again. All right, so every single game object, all it brings to the table is a generic transform, which is three bucket arrays called vector threes, one representing position, one representing rotation, one representing scale. All right, so now instead of working with a generic game object right now, we're working with a more specific game object. We're working with an instance of a cube. All right, so we see these cubes have all these other things that are down here. Now, one of these things, so these are, they're called components. If we go back and click on our generic game object, you see how we can say we can add components to this. We're going to be doing that plenty, so I'm not going to mess with that right now. But back to the cube, we already have some components that have been added. One of these guys is a mesh renderer. Now, when we see the word renderer, that means what do we see? So if I click this checkbox next to the mesh renderer, what I'm doing is I'm disabling it, and that'll make our guy disappear. So no longer is he seeable in the scene. So if you look at the bottom right-hand corner where the camera is, so sometimes what you'll do in a game is you might put something in the scene where it will be, and then you turn off its renderer so you can't see it until you're ready to see it. And then you programmatically turn its renderer back on. All right. You can mess with shadows. So if you say, I don't want it to cast shadows, you turn off the processing for shadows. So the shadow disappeared. If I turn it back on, the shadow appears again. Now, you might say, well, don't I always want a shadow? Well, every single time you add new things that physics has to deal with, you're adding a little bit more computation that needs to be done for that scene. So if you think about your mobile video game systems versus your big Xbox or something, the difference is that on the mobile, a lot of times the graphics are dumbed down some. Either the textures are smaller, so it requires less memory, or there are things like shadows or water effects, things like that, things that only add a little bit of razzle dazzle to the scene, but take a lot of computation power. So what these mobile games do is they turn some of those things off so that from a player's perspective, not that much has changed. But from a computation perspective, they've taken a whole lot of heavy lifting off of the processor or the graphics, the GPU that's inside of that gaming device. All right, so this kind of gives you a look into how do they make mobile games look as good as possible or look as close as possible to the desktop version of the game without giving up too much quality. All right, so now what I'm going to do down here is we are going to add something to this guy. All right, so right now what we have, we're going to forget about Mesh Renderer for right now. We don't care. We want him to show up. We're going to not even worry about this mesh filter, frankly, at all in this class. It has to do with performance and dealing with cubes. All right, because we create a mesh around it. It would look like a blanket that kind of goes over this guy. You can think of that as being a mesh. All right, so now in our games, we have things called colliders. Now, a cube comes with a collider built into it. We can remove it if we want to, or we can disable it, but it's called a box collider. Hence, a cube being the shape of a box, we have a box collider. This is something that fits the shape of this box, this cube perfectly, and allows it to detect with this game object, that is the game object that this component is hanging off of, with this game object collides with another game object that also has a collider of any kind. So colliders bump into other colliders. Okay. So this collider is turned on right now, whatever, doesn't matter. We're going to ignore this for the moment. All right. Now, what I'm going to do is I'm going to add a new component, and we're going to add something called a rigid body. The normal rigid body, not rigid body 2D. Whenever you see 2D stuff in Unity, um, think of it as somewhat of a bolt-on hack. Unity is a 3D game engine, so it was developed to do things in 3 dimensions. Now, a lot of people had been using other like tools like Game Builder and things like that that were kind of made for building 2-dimensional platformers. And Unity was trying to capture in the very early days some of that audience for building 2D games. So they have things built into it for doing 2D game design. Um, I haven't messed with it in a long time. It's still in the game engine, so presumably it's evolved a lot. But in the early days, at the very least, it was sort of kind of considered like a bolt-on hack. So most people who were serious about building 2D games still built them using other tools, but this was Unity trying to get people to come over to the dark side, if you will. But in here, we are not going to be messing with any 2-dimensional stuff, just 3D. All right. So we added our rigid body. Now, when you hear rigid body, what I want you to think of is solid object. All right. So it went from being something that looks like a cube to something that now has mass. It's a physical thing that if you picked up in the real world, you imagine it might have some weight to it or something like that. So we can set the mass, we can set all sorts of other things. I don't know what every one of these things means, but other variables about them that might impact how this thing is impacted by um, uh, other physical forces, things like that. All right. Now, notice that when I added the rigid body to this guy, by default, this line that says use gravity had a checkbox next to it. All right, so I'm going to uncheck that for a second. I'm going to go ahead and hit play. All right, so there's our scene right now. Now, here's something that's interesting that you can do while your game is currently running. But put a huge, I don't know, exclamation point or pay attention to this, whatever, in your notes. And this is something that I'm also warning all of you to make sure you call me out on when I screw it up, because I miss this all the time. That's why I'm pointing it out. One thing that's cool that you can do while you're playing your, messing with your game is you can manipulate things over here and see what happens. You can change the position of this guy. So maybe I change this to -2, something like that. Or I change it to -1. So I can move his position like that. So I just changed his X to -1. But when I stop the game, notice it changed back. So anything you do while that game is running gives you can manipulate it on the screen. Maybe you get this guy positioned exactly where you want him, but until you have actually done that outside of this. So, one thing you can do is you could say, I want to copy. Well, let me move him first. So I'm going to move him to what do I have about here? -3. Okay, there's -3. I'm going to right click on position and I'm going to say, I'm guessing it's just copy. I recalled it being something different before. Oh, okay, you can do it up here now. Okay, so I've moved my stuff into where I want it to be. The only thing I've changed is stuff with position. So I'm going to hit these 3 little dots next to transform. Notice my game is currently running. I'm going to hit those 3 little dots. I'm going to say copy position. All right. Now you could also copy an entire component if I made changes to all of this, but I only made a little change to position. So now I'm going to stop this. You're going to notice that our -3 is going to go back to what it was before. But now I can come in here and I can say paste position and it'll move it where I want it. But you want to remember to do that if you're using real-time gameplay to kind of, move things around. Make sure you've either written down what the number should be or you've copied the component, so you can actually set the future truth of what's going to happen with that guy to the that new value. Okay, so we're going to go ahead and go back into this. Oh, was I already running it? I was already, well, whatever. I wasn't. I stopped. All right, so now my guy here is still hovering a little bit. All right, now remember we unchecked use gravity. So I'm going to recheck use gravity. We saw him fall out of the sky. All right, now let's put him up a little higher so we can actually see him drop. All right, and we can scroll out here. Now, if you're using a trackpad on your computer, you might find you can get good at using it with a trackpad, but you might find using a standard mouse to be better, especially when you start rotating around objects and stuff like that. Just something to keep in mind as you mess with this stuff. You'll gain a skill at manipulating the interface. You're not going to be very good at it initially. All right, so I'm going to kind of put this guy off the scene here, although we still technically see his shadow. I can always click on the mesh renderer here, and I can go and turn off lighting, shadows. I can turn that off. So you no longer see a shadow, just in case that was meaningful to us. So when we run our game here, it's as if we're looking at an empty scene. But if I turn gravity back on, this is during runtime, so this will not stick. This will undo later. If I turn gravity back on, our dude falls out of the sky. Okay. So we can turn on and off the various physics stuff that we want to have going on. All right. Now let's think about colliders for a second. So first of all, I'm going to go ahead and turn off the box collider for that guy. You saw him fall through, right? All right, I'm going to reset this. All right. We'll go ahead and turn gravity on for him again. He'll land because the box collider's turned back on now. Now I'm going to switch over to the ground. That's the plane we originally put down, this whole big thing here. Notice he has something called a mesh collider. All right. I'm going to turn off the mesh collider. Colliders collide with colliders. So if you want things to interact with each other, they have to both have a collider enabled on them. All right. So when I turn off either the collider on the ground or I turn off the collider on the cube, they no longer collide with each other. They both have to be there. All right. So we'll stop this. The colliders are both back on now. All right, now something I'm going to do is I'm going to go to my cube, and because I've now moved it off the scene, I'm going to go ahead and double click on cube, and that's going to move me to kind of have that guy centered. All right. Now what I'm going to do is I'm going to mess with the rotation a little bit on this guy. All right. I want him to fall kind of pin first, so he doesn't hit the ground as like a flat thump. All right, so I've done that. Notice the game is not running right now, so those changes are real changes that'll stick. We see the rotation has now moved to something else. All right, I'll go ahead and run my game. Again, remember, for cube, we still have gravity disabled. Now I'm going to go ahead and turn gravity on. Remember, we still have two colliders. These colliders will interact with each other, but I've turned the cube in such a way that hopefully one of its edges, one of its points hits first. So we get to see the follow through. What happens after those colliders collide? So when I turn this back in, that guy drops out of the sky and he behaves like we imagine dropping a block out of the sky would behave. All right. These are all things game engines do for us, and all we've done is click the couple of check boxes. All right. So if you go back to early on in the course, well, I repeat it pretty often, but I say things like all hard programs are made up of a bunch of easy parts. So now we can expand that to say that video games, while looking visually amazing, do not actually have too much of that amazingness coded into them. Most of the visual things we see are done automatically by whatever physics engine the company's using. Many small, medium, and independent game developers are probably using either Unity or Unreal Engine to do all their development. Now, if you're a big AAA company like, Blizzard Activision or something like that, you probably have your own internal proprietary game engine that you've been building over the years. In fact, that's where Unreal Engine came from. Years and years and years ago. I mean, man, this is probably back in the 90s now, or at least early 2000s. There was a first-person shooter type game called Unreal. And Unreal Engine was the engine used by Unreal. And it was considered to be like a game changer. It was way ahead of its time. It was a fairly famous game because of the leap it made. Well, eventually they made Unreal Engine available to everybody instead of it being only a proprietary tool used internally at the company. I'm not sure if the company was called Unreal or just the game was. Somebody can fact check that. I don't remember, but at least a good portion of what I just said is based in fact. The gears might be off a little bit. Who owns the company might be off, but I'm pretty sure the game was called Unreal, and this was definitely their proprietary. Well, this guy's competitor was definitely their proprietary game engine. Uh, so in any case, if you're a small, medium, or indie developer, you're probably using either Unity or Unreal Game Engine. it's iOS versus Android. You're going to have people who are proponents of both. Nobody, I mean, nobody in their right mind is using Godot. Uh, is that right, Logan? Is that how you pronounce the stupid one? I actually think Godot's gaining quite a bit of traction, but we'll see what happens. All right. So, but in any case, if you build up a skill in Unity and then you go and work for a company that uses Unreal Engine, let's say, you're going to pick up on Unreal Engine real quick. So much of the stuff we've talked about today translates almost identically over to Unreal Engine. Instead of a rigid body, it's called something else, things like that. All right. Not a major deal which of these tools you learn first. They each have their pros and cons, and each person gets to decide what feels better to them. Um, Unity uses C Sharp as its scripting language that we're going to look at here in a few minutes. Um, whereas Unreal Engine uses C++. But frankly, both of them, when you code for this, you're using kind of you have available the entire language, but you're really using the programming language C sharp or C++ to call upon the objects that are built into that ecosystem and then just calling methods on those. So frankly, at the end of the day, the code looks almost identical. There isn't all that much specialness to it being C++ or C sharp. Uh, uh, Unreal Engine has also, they were kind of the industry leader in adding in some kind of what you see, what you get type coding. So drag and drop type programming that allows you to handle some workflows that aren't maybe too complex. So if you're not a programmer, you can use some of these things, and that's actually an interesting thing to consider, at least for a second. And this is very related to our current world in AI. You can accomplish a shocking amount of stuff using AI without being a programmer. You can put in a couple of prompts and poof, you have an iPhone app, or you have a video game, or you have a utility app, something like this. These are going to be great for like personal projects, personal utilities. Most of the crap that I write for my own personal utilities or bots that I have running. I have a couple of different agents running on different computers in this room right now that are doing things for, my businesses or something like that, automating processes. You know, so if you're someone who is doing very, you know, kind of save time things for yourself and you don't really have to worry about other people using your software or having convenient ways of doing things, as long as I know how to start the process and I know command line Unix, so I can just set up cron jobs and stuff like that for the things to launch at the right time. These are not things that are difficult for me, but I'm a technology person. But if I was a person who doesn't know how to code or doesn't know as much about technology, you might only be able to get 80% of the way there with some of these AI tools, and you might have a working code that you don't know how to run, or you don't know how to take it that last step. So it's kind of an important thing for us to remember as software engineers and technologists is we shouldn't be afraid that AI is going to take our jobs away. Even saw um, a thing last night on one of the news channels. I don't remember which one it was, but I mean it was interesting. But it was a research group that went through, and they were looking at kind of predicting which jobs are going to be the ones that are going to be most likely to be replaced. And they did say that this doesn't appear to be happening yet. So I think this is more of a future thinking AI thing. But right at the top of the list was computer programmers. And I think they're wrong. And I'm usually pretty right about future and tech stuff. So I don't know, take my track record for what it is, but I've been wrong before, contrary to my personal belief. But I use this AI stuff for coding stuff all the time, and it's doesn't feel like at this point the direction it's going that in the immediate future, let's say next 3 to 5 years, that it's going to come anywhere close to fully replacing software engineers. Now, what it might do is it might replace some junior developers. Um, and that was kind of an interesting thing. And I've kind of heard some similar stuff. So as a, experienced software developer, when you're working at a company, if you're a senior developer, you're probably working on the harder parts of the projects. If you're a junior developer, you're working on the simpler, more grunt work part of the projects, let's say. So you're a generalist instead of a specialist. Now, I could see some generalist tasks being taken over by AI. So one thing a software engineer said on this news piece that I thought was interesting is a senior software engineer or an architect mentioned that, it's having an AI agent that he works with is as if he has a junior developer he can hand things off to and go get done, except it happens in 30 seconds instead of however long that junior developer took to do it, and then however long it took to debug their code. Um, I can see situations like that shifting in industry where what's going to happen is that the people coming in who are junior developers today, their jobs are going to get replaced. That doesn't mean that new software engineers are not going to be hired. Just the role is going to demand a higher skill set, which means that people in college today need to become even better programmers than they were before because they need to set themselves up apart from the simple, uh, they need to set themselves apart from the trivial coding things that these AIs can do so much faster than any human can. All right. So what we're going to see is a redefinition of the kinds of problems that are geared for humans versus the ones that are geared for AIs. Now, 10 years from now, if we have super intelligence, we might be having a very different, conversation where we're all out of work and, money's no longer a thing. We all basically live in a utopian society with robots doing all the work for us. Um, Sounds nice on paper, but that feels like become a pretty boring society pretty quickly. Um, I've tried to retire twice in my career, and because I have plenty of money, and in neither case did it stick because I felt like a bum. I wasn't doing anything. So I think there's an aspect of humanity where we want to feel useful. We want to feel like we are taking advantage of our God-given gifts. And I don't know. I guess maybe you disagree, but in my mind, one of my skills outside of being a good programmer is that I can explain complex tasks, complex technology stuff in a relatively clear way to people where a lot of technology people struggle with that type of thing. Now, maybe I'm deluding myself, but I believe that's my God-given gift. So I felt compelled to come and teach the stuff that I had already been doing because I don't want to sit around and code for other people all day long. Um, but having nothing to do for work is not as fun as it sounds like. Maybe for a year. Do it for a year, then go find something that you enjoy doing some. Um, Okay, so I don't think these AIs are going to take over, um, just like these game engines didn't take over human beings doing stuff, because there's no reason why you can't write Unity scripts with AI right now. We're going to probably look at some examples of those things. Just the dynamics of what computer scientists are going to be doing, because in that same news interview, well, these are two separate conversations I had yesterday, actually. So on one hand, we have um, uh, these people crying wolf, let's say, in my opinion, that software engineers are going to be a dying breed. They're going to be the industry most impacted by AIs because AIs are really, really, really good at structured coding because it's very discrete. It doesn't require a lot of unique intelligence. It's just kind of paint by number, that because programming is so discrete, zeros and ones. It shouldn't be surprising that it's good at it, but it doesn't have human creativity. And it's the human creativity that has allowed us to keep having new features, cooler features, things that an AI could never think of because an AI wasn't trained on that data. Once we have those new features, AIs get trained on that data. Now they'll start incorporating those things into the software they're generating, and humans will need to use their creativity to figure out the next cool thing to do. All right, so this is just the reality of human intelligence, but notice that humans are involved in every one of those conversations. Now, I had a meeting yesterday also with marketing, as we have our new online programs in applied AI as well as a master's of AI. And, they've done all this market research and things like that. By far, right now, the hottest college degree is computer science. So the most number of people who are coming to college for degrees are coming for computer science. Yet we have the news saying that computer science might be a dying breed. It's going to shift. The things that we will do as computer scientists will leverage the AIs to make ourselves more productive. And then as human beings, we're always going to stay ahead of that curve and get more and more creative, but we need to be lifetime learners. We need to stay ahead of the robots and keep giving ourselves more and more skills. All right. So in any case, colliders collide with colliders. Rigid bodies make things feel like they have mass. Without a rigid body, it doesn't drop. It can't drop. With a rigid body, we can choose whether we want gravity to have an impact or not. Right now, when I turn gravity on and off, it doesn't matter because we have colliders colliding with colliders. But if I turn the collider off, it falls right through. All right. So this is actually, and the main reason I'm showing you this live, and I want you to really throw it into your head, that way you can fix my mistakes when I make them on purpose, is because I tend to be kind of the absent-minded professor mentality. If the game is running and you make changes over on the side, those changes will not stick. I often will on purpose forget that. And I will start messing with stuff back out here as if they stuck. So it is, well, I don't really want Coffee to be the one to remind me. She's always late to class. So maybe Logan? Logan, you're in charge of reminding me when I purposely mess up. All right. Perfect. We have a plan. All right. So now, just in our last couple minutes here, just so I can get you over to the coding side of things, because you'll do plenty of practice manipulating things like we just did. So you kind of just got a taste for stuff. Down here on the bottom, you have this area called assets. So whenever you build a project, that project comes with a folder that sits in it called assets. All right. And inside that folder, we have a default folder called scenes, as well as some other crap. Don't worry about those. All right. Also, don't worry about some of these over here for the input system stuff. You'll actually play with that with Rollerball, and I'll actually do the Rollerball thing too, because the input system stuff seems to change every single year. And I think the last time I did this would have been a year ago. So I actually prefer the old input system where we had to code most of it. It wasn't like tons of lines of code. It was like 10. But now they have like a built-in thing for making, responding to the arrow keys and driving your dude around and stuff. And I don't like it as much, but it's meant to be easier. All right, so don't worry about that for right now. The tutorial will go through some of that stuff. But now what I usually do is I usually right click in my assets thing and I usually create a folder. You don't have to. Anything that's in assets is accessible in your entire project. This is for human organization only. So I usually create a folder and I usually call this guy scripts. So this is the folder where I'm going to keep my programming stuff. All right, now I'm going to go in here and I'm going to right click. So I just double clicked on the scripts folder and I'm going to create, and I can create stuff. All right, so under scripting, I have something called a mono behavior script. I also have something called an empty C# script. We are going to use that heavily as we start bringing in our dungeon crawler backend code to work with our front end interface that is our 3D thing here. All right. But initially, I'm going to create this thing called a mono behavior script. Now, what this is going to do is it's going to give me a C# class that extends a class called mono behavior. All right, and we're going to call, well, I'll just leave it as new mono behavior.cs. All right, so this gives me a script. All right, now I'm going to go ahead and double click on this script. Now, by default, well, let me go ahead and see what it opens in. It should open up in Visual Studio Code by default, but if it doesn't, I'm going to show you how to fix that. And we don't know what's going to happen because I have a zillion different IDEs on this computer for depending on what I'm doing. So I'll double click on this. And it opened it up in Visual Studio Code. All right, so I'm in the right place with it. But let me just show you real quick, just in case it didn't take you to Visual Studio Code and it opened up in like text editor or notepad or something like that. So in Unity, I think I might have to hunt and peck a little bit, maybe under in Unity under settings. It's called external editors is what I'm looking for. So yeah, external tools. So when I went to Unity settings, or if you're on a Windows machine, I bet you it's under like file settings or file preferences, something like that. But in here under preferences, you're going to see something called external tools, and you're going to see external script editor. Go down and pick the one that you want or browse to the program you want it to open for that thing. The default's probably going to be Visual Studio Code because you're probably going to either have already had that installed or you installed it with your um, uh, install of Unity. But in any case, if it opens in something else, this is where you come in to fix that and then browse to wherever Visual Studio Code is. And from that point forward, it'll open it in the right place. All right. So Visual Studio Code will look like this. Okay. All right. So notice here that even though this is the first time many of you are seeing C#, it should not look all that all that unfamiliar to you. It looks a lot like Java instead of import, where you, well, actually uses something called namespaces. I'll talk about it at some other point in time, but you could think of this as a package in Java. Um, then we have our public class, same thing as we have in Java. The name of this class is new mono behavior script because I didn't change the default name they gave me. And instead of the word extends in C#, we use a colon, and this guy extends this class called mono behavior. All right. Now, mono behaviors that is the built. I want you to think about this kind of like the thread class that we looked at in Java, in that there is some magic inside of mono behavior that is directly integrated with the way Unity does things. All right. So, for example, you notice here that by default, it's given me two empty methods. One is called start and one is called update. And notice it tells you what these guys are. So start, you can think of as almost being like the constructor for that particular instance of the object that this script is going to get attached to. So right now we've just built this script. We're going to take this script and we can hang it as a component on one or more of our game objects. So for example, if you from our rollerball game, you had those collectible things that you saw spinning on the screen. Every single one of those guys is behaving using the same script. You write the script once, you hang it on those 10 or however many you create game objects that all look like little yellow diamonds or whatever. And what does it do? It makes them all rotate around and look alive. And that's just because of a single script with probably 4 lines of code in it. So start is all the stuff you want to have happen when when the game object that this script is attached to first comes into existence. And then update is this is the stuff that will happen every single frame of your application. So if your graphics card can run something at 100 frames a second, this will have this function right here will get called 100 times every second. All right. So the tutorial that you have assigned will have you go and practice through these things and see how these things work. But I think I've introduced enough about the tool for you that you'll jump in and realize it's not that major of a deal. You're not going to be writing zillions of lines of code. Most of this tutorial is going to be marrying the programming side to the using the editor side of things. Okay? So, questions, comments, concerns, bribes. Okay. So assignments up. It's due before class starts or by the beginning of class on Tuesday. I will see everybody then. Back in class, normal class. Godot is based. Is that a so is that mean Godot is like epic? Did I already lose Logan? Can you to explain it to me? Oh, he's still here. Or did he just go away and stay connected like Coffee probably did too? They've logged on,
No,
they
I'm still here.
they wander off. You're
No,
still
I'm still
here.
here. I just thought you were gonna say something massively important at the end that made me want to
Everything I say
stay.
is important.
Well,
Well, okay, yeah. Oh, so Logan, you said it means based. I get it. So, so help me. So in context, I'm getting. You're saying Godot is the best. I understand. So based is based like a synonym for the best, or like it's epic, or it's you know, or is there not really a direct translation? It's more of a feeling or something. I got nothing. He's trying to come up with what it actually means.
just
It's
trying to write out
well,
his
it's like
answer on chat.
I do the same thing with my nephew. My nephew's well actually he's probably Logan's age. I'm guessing Logan, are you 18, 18, 19? Um that's the age group, right? Like Coffee, you're 18, 19.
Dr. Lemon, I had a question when you're done.
Well, I asked you your age first.
Oh, me or Logan?
Well, both. Are
Oh,
you guys are like 18 or 19,
yeah,
right?
19. Yeah.
Yeah. So you're like the same age as my brother's oldest boy.
Oh,
So I learned today's lingo from him. But
oh.
but go ahead with your question.
So I remember you giving me helpful tips about, looking for internships and everything, and I've found some really good options as far as like looking online. But I wanted to ask because